Interestingly, in this whole similarity-based distribution approach, we get lots of linguistic regularities. For example, in those higher dimensional space, if I try to draw the things in 2 dimension, so what we are going to get in this model, that the relationship between man and woman and the kind of king and queen are almost similar. In this particular diagram, you can see that if we move toward right, toward x-axis or maybe a little up, from man to woman changes are happening. Here also from king to queen changes are happening. Similar to this, if we try to find out uncle and aunt, so we get uncle here, aunt here. They will also have the similar directions or relationship. This applies almost every categories of words. For example, if you take the name of the country and the capital of those countries, so let me draw that one. Japan and Tokyo, they have a relationship toward these directions from here to here. Let me draw the relations in different color. Similar to this, that means from a country, if we move toward these directions, we are going to find the capital for those countries. So that's supposed to be the direction for each and every countries and their capitals. For Spain here, and Madrid here. So they will have a similar directions like whatever we have for Japan and Tokyo. And we have maybe China here and Beijing here. So they will have the similar directions. Okay. Due to all these linguistics regularities in those higher dimensional space, this content can be manipulated to perform some simple arithmetic operations on this data, on this text data. Yes, simple arithmetic operations. For example, from these whole calculations itself, if I write down Japan minus Tokyo plus Madrid, Japan minus Tokyo plus Madrid, we are going to get Spain. We are deducting Tokyo from Japan. We are adding Madrid there. So we are going to get Spain. So these particular kind of arithmetic simple operations we can get from these word to vec representations, from this high dimensional word representation. This can be manipulated or this can be used in different applications for different purposes. But this is pretty interesting. And if you change this sort of sense, like from Madrid, if you do kind of Beijing, so you are going to get China here. Okay, I can try to show like some simpler examples. Similar to this is very simplified example, may not be happening in real life. You have to deal with very high dimension of data. This is just for your understanding point of view. Okay, so we can combine two of these vectors to find out some complex relationship. For example, Russia plus river, you are going to get the different rivers from Russia. And similar sort of things we will try later in that particular discussion. Before that, let's jump into our discussions on what kind of models we are going to use.